This is Accelerated Geometry, Section 3.3, Constructing Perpendiculars to a Line. So sometimes we wonder, why do we want to do some of this stuff? And here is one of the reasons. You want to have the internet cable connected to your house. And it says, suppose you wanted to connect the building to the internet cable using the shortest possible length of connecting wire. How can you find out how much wire you need so you don't buy too much? Well, if I want to connect from a house to a line of an internet cable, it's probably going to be a perpendicular line that's going to come down to go from the house perpendicular to the cable that is already there. And if I do it in a perpendicular manner, I won't be wasting any of the wire. So that would be one reason why we would want to connect perpendicularly to a line. So there are two constructions that we're going to learn today, and then we're going to apply them to the construction of an altitude of the triangle. So the first one is to construct a perpendicular to a line from a point that is not on the line. So if I go here, I will draw a line, and here's a point that is not on the line. And I'm purposely making it so it's not anywhere near the center of that line. Okay, there are steps that are shown on your class notes. And the first step says stab in at the given point, open your compass past the given line. So here's the point, and I'm going to open this up past the given line. And then I'm going to swing the compass so that the arc touches that line in two spots. So stab in at the given point, open your compass past the given line, swing your compass to create two arcs through the line. Step 2, stab in at each of these two arc intersections and create two new arcs that intersect above or below the line. So I will do this below the line. So if I stab in here and make an arc, and then if I stab in at this other arc intersection and make an arc, I now have 2 points that are on the perpendicular bisector of this helping segment. Okay, so I made this helping segment here. The helping segment goes from here to here. This original point is the same distance from that endpoint as it is from that endpoint, so it's on the perpendicular bisector of the segment. And then I created a point here that is the same distance from this endpoint of my helping segment as it is from that endpoint of the helping segment, so it's on the perpendicular bisector of the helping segment. I need 2 points to determine a line, so I connect those 2 points now, and that is the perpendicular bisector of the helping segment. But more importantly, it is perpendicular to the entire line itself. Okay, then the second construction of the day is, here is a line, and here is a point on the line. And I need to construct a perpendicular to that line that goes through that given point. So the first step is stab in at the given point and create an arc with the same compass opening on each side of that given point. Okay, so now that point is the same distance from each endpoint of my helping segment, so therefore it is on the perpendicular bisector of that helping segment. Second step, stab in at each of these two arc intersections and create 2 new arcs. So there's one, and here's the other. Oops, here's the other. Okay, that point now is the same distance from each endpoint of my helping segment, so it's on the perpendicular bisector of the helping segment. So since those are both on the perpendicular bisector of the helping segment, if I connect them, I will have the perpendicular bisector of my helping segment. So not only is it perpendicular and bisecting the helping segment, but more importantly in this case, is perpendicular to the entire segment. So those are the two basic constructions of the day. And now we go back and we talk about a definition. An altitude of a triangle is a segment that goes from a vertex perpendicular to the opposite side of the triangle or a line containing that opposite side. Okay, so this is no problem. It goes from the vertex perpendicular to this side, so it is an altitude. Now in the second triangle, if I go from the vertex perpendicular to the opposite side is not long enough, so I need to do an extension of that side. When I extend that side, that opposite side, now I can go perpendicular to it from the vertex, perpendicular to the opposite side or an extension of it. Sometimes in a right triangle, this happens. If I go from this vertex perpendicular to the opposite side, it's actually the side of this right triangle. So this is actually an altitude of the right triangle. Same thing here, if I go from this vertex perpendicular to the opposite side, it is also the second side here of this right triangle. So altitudes can be inside the triangle, altitudes can hang outside of the triangle, and altitudes can actually be sides of the triangle. So now this says, sketch the altitude from A in the triangles below. Now, how I do this is, let's see if I can do this. Let's go over to my drawing instead. Okay, so this one has a triangle that looks like this, kind of. Okay. Now, what I want here is an altitude from A. So here is A. Now, I can picture this because I've done math, for many, many years, and I don't have a problem doing this. But if you're new to this, see how I am lining up. See how this ruler has a 90-degree angle there at the corner? If I take this side of that ruler and slide it until the second side touches point A, I can then draw a line in here, a line segment that goes from A to this opposite side perpendicularly, because this corner of my ruler is a right angle. So that is how I would sketch the altitude from A in that triangle. The other triangle that they have is an obtuse triangle, and the obtuse triangle looks like this, kind of. And over here is my A. Now, I want to go from A perpendicular to this opposite side. Now, how do I know what the opposite side is? It's the side that is not sides of the vertex angle. So these are vertex sides here and here, which means this is the opposite side. So I take my ruler and I slide this. I put the edge of my ruler on that line, and I slide it until it touches A. Now I have a problem because I've lost my line, my sliding line. So I go back here and I extend this. Okay, now here's my ruler going along that side. That's the opposite side. I keep sliding it until the other side touches A. When it touches A, I can draw in that side, and there is my altitude hanging outside of the triangle. Now, what if I had a right triangle? So here is kind of a right triangle, and this is where they put A. Okay, I want to have A here. Those are the two sides of angle A, so they come here and here, which means this is the opposite side. So I'm going to slide this ruler. I'm going to have a hard time sliding that ruler because the camera base is in the way, so I'm going to get a piece of paper here. So here's another 90-degree angle. So I'm going to slide this along that side until it touches A. And when it does, it's right here. So here's the case where the altitude is actually a side of the triangle, and that always happens in a right angle. Okay, then the next thing they do is they say, yeah, you had fun sketching those, but now what we want you to do is to construct these. Okay, so I'm going to go back, and I'm going to try to do the same kind of shape. So here is a triangle that looks kind of like, how should we do it? Like this. Okay. Okay, here's A. Now they want me to construct the altitude. Okay, so I need to construct a perpendicular from a point to this line. To do that, I stab in at the point. I open up my compass so it's a little bit past the line, and then I swing an arc. If my arc does not go through in 2 spots, I make my line longer. And now from this point, I make an arc. And from this intersection spot over here, I make an arc. And so therefore, when I connect from A to that intersection spot, that is the altitude of the triangle. Okay, this time I'm going to try to create an obtuse triangle. Here is A. Okay, so up here I sketched it. Here I'm going to try to construct it. To construct it, I stab in at the vertex, go a little bit past the line. Ah, the line is missing again. So I do an extension of that line. Okay, so again, stab in at the vertex, go a little bit past the line, and swing an arc that touches that line in 2 spots. Either above or below the line. This time I'll go below it. Make an arc from each of those intersection spots. And now connect the vertex to that intersection spot. And now I have created an altitude. The altitude goes from here to here. This was just a helping line. This was just a helping line. So this is the actual altitude. It's hanging out here. We'll call them Al, A-L. Okay, and then if I have a right triangle, okay, here is A, and I want to construct an altitude from A. I have to extend the opposite side again, stab in, go a little bit past, construct an arc that touches in 2 spots. From each of those spots, create an arc, and look what I see. It is the actual side of that triangle. Okay, so we have covered, I think, everything so far with the constructions. There is a group investigation that follows this, and in this group investigation, they want you to do this. They want you to find the shortest distance from a point to a line. And so they ask you to draw in a bunch of them and measure them. So this one measures 6, this one is 3, this one is 4, this one's 5. The shortest one is actually this one right here that goes from P to M. And what you will notice is that is the perpendicular distance. So the shortest distance from a point to a line is measured along the perpendicular distance from the point to the line. And that's the end of this presentation, so you could turn this off now.